Okay, guys, we're going to just finish up what we learned about planes from C3 and C4. So we learned that we can have a scalar, vector, and parametric equation of a plane. And we talked about how to make equations of planes from points on the plane. So we could have like 3 points on a plane, or we could have 2 direction vectors and a point on a plane, and we talked about how to make equations of them. So I just want to talk to you about the scalar equation of a plane right now. Okay, so let's say, actually first let's start with, so we're going to figure out how to make scalar equations of planes. So let's talk about if somebody gave us a normal vector to the plane, like the vector 3, -2, 5, that's a vector that's perpendicular to our plane. So if this is what our plane looked like, it would be a vector that's coming off the plane perpendicular to the plane. That would be that vector. It wouldn't be a vector that's parallel to it. It'd be perpendicular. And let's say we know a point, let's call it P0, and it's 1, 2, -3. And we'll say that that point is right on the plane. So if we know that information, then we actually know that the scalar equation of a plane, say it's ax plus by plus cz plus d equals 0. We actually know that even from when we were talking about lines, the normal vector is actually a, b, c on our scalar equation. So that makes this question pretty easy. So we can actually just sub in 3, -2, plus 5 for A, B, and C. Now we don't know D, but we do know this point, so we can sub this point in for x, y, and z to find D. So 3 times 1 minus 2 times 2 plus 5 times -3 plus D equals 0, and then we can just solve for D. And if we isolate D, we find out that D equals, I think, -15 plus 3, 12 minus 4. I think D is going to equal 16. So now we know the scalar equation of our plane will be 3x minus 2y plus 5z plus 16 equals 0. So it's very easy to get the scalar equation of a plane if we know the normal vector. That's awesome because that's just what the coefficients in front of x, y, and z stand for. Okay, let's say we didn't know that information though. We really wanted to write the scalar equation of a plane. So let's say we just had points. So we want to write the scalar equation of a plane. And we have the point -3, -1, -2. And then we also have 4, 6, 2. And we have another point, 5, -4, 1. So we have 3 points on our plane. And we want to find the scalar equation of the plane. Okay, so first we're going to need 2 direction vectors on our plane. So wherever we have 3 points on our plane, so just pick 2 of them to make a direction vector, and then pick another 2 to make another direction vector. It doesn't matter which ones you pick. So let's just say we go for vector AB. So we want to create vector AB, so B minus A. So that would give us 7, 7, 4. If we're doing 4, take away -3, 6, take away -1, 2, take away -2. So we have that direction vector. And let's also do AC. So now we're doing C minus A, which will give us 8, -3, 3. So now we know 2 direction vectors on our plane. Now, remember we just talked about how in the scalar equation of a plane, ax plus by plus cz plus d equals 0, we know that the normal vector is the coefficients a, b, and c. So what we need is, we need a perpendicular vector to this plane, and we know that that will also be perpendicular to AB and AC vector. So basically, if you want to find a vector that's perpendicular to two other vectors, you can use the cross product. So if we take the cross product between these two vectors, that will give us the normal vector. So if we set up the ijk thing, 774, 774, 8, negative 3, 3, 8, negative 3, 3, and we do that, like this whole thing, we will come up with the normal vector, which I already did ahead of time, and I got 33, 11, and negative 77. Kind of big. So if you do cross product, that's what you get. Now, I noticed that these are all divisible by 11, so I'm going to divide them all by 11 just to make it smaller. So instead I'll do 3, 1, negative 7. That looks a lot better. So I just divided everything by 11. Okay, so now I know the coefficients a, b, and c. So I got 3x plus y minus 7z plus d equals 0. So I can sub in the a, b, and c for my normal vector, but I still don't know d. But I do know 3 points on my line. So why not pick one of the points? Let's just go with a and sub that in for x, y, and z. So a was negative 3, negative 1, and negative 2. And solving that equation, we'll figure out that d is equal to negative 4. So our final answer is 3x plus y minus 7z minus 4 equals 0. Scalar equation of a plane. So even if we're given 3 points, we can create two direction vectors, do the cross product to find a perpendicular vector, which is this guy, and then now we can sub that in for a, b, and c, sub a point in to find d, and we're done. Awesome. What else was I gonna say about planes? I think that's it. So at this point, we should be able to go from scalar to vector to parametric in all different ways. Okay. Just thinking. Yeah, I guess that's it. Okay, sorry for the delay.